let me start thanking the competition organizer. It was very amazing journey that we compete and learn at the same time, and it was very valuable for me. I began my presentation with a brief overview of myself, and then as you can see, I go to the details of my approach and my models. I have a bachelor and master degree in telecommunication engineering, and I have a PhD in economics. After 2 or 3 years that I work in the telecommunication engineering field, I changed my course and I began to work during past 15 years primarily as an analyst and investment manager. Recent development on AI and also this big hype on LLM got me exciting to go to more details about AI and machine learning. And with my background in C programming language and my engineering background, during past, I think, 10 or 9 months, I put hard work to learn Python and machine learning algorithm, and I think that's hard work during past 10 months helped me a lot to succeed in this competition. To begin with my approach, I think it's good to start with time series. It was a challenging part of this competition. To extract useful information from time series, I used the K-means clustering algorithm with 15 clusters to extract useful information from time series data. For that reason, I picked 6 parquet files, 2 most variant files from each classes, and then I combined this data set together and then fit K-means cluster algorithm. Then I use this fitted model to extract cluster from other time series data sets. I assume that each cluster could represent a movement in parquet data. So I average each cluster value over the time duration, and then I use this average as a feature for each user. By doing that, at the end, I have 15 features per user that I believe could represent the average of some kind of activity during the time that the user used the actigraphy watch. Another challenging part of this competition, I believe, was choosing the right target. After some initial submission, I found that using threshold optimization could simply lead to overfitting and inconsistent result. So I decided to ignore optimization completely and use PCIAT total as target label, and I applied a fixed threshold to change the target variable to the competition target variable. Since the exact value between this threshold was less important than the relative position to the threshold for final prediction, I further binned the PCIAT total into 10 bins and adjusted the threshold accordingly. A big portion of data in the training data set was unlabeled data. So I decided to use a semi-supervised learning approach or pseudo-labeling to predict the label of this unlabeled data and to use them with other data to train my final model. So I decided to use an ensemble of models. I used 5 models for this purpose: 3 gradient boost and decision tree, 1 neural network, and 1 lasso regression model. I then combine and assemble these models using hill climbing, and then I use these whole models to predict the label of unlabeled data. And then for my final prediction, I train my model, use both this predicted label and the original label that we had in data sets. For my final prediction, I also use an ensemble of models. Again, 3 gradient boosting decision tree, 1 simple decision tree, 2 regressor model, and 1 neural network. I train the models on the entire data set and validate it only on original label in my cross-validation approach. I use sample weight proportional to frequency of every sample in my regressor, and I should admit that I got that idea from Leonard from the notebook that he published in discussion forum, I think. I also applied hard voting to ensemble these models and use the data which I was derived from my semi-supervised learning. In this picture, you can see the summary of what I've done for my models and the workflow of data from the beginning to the final prediction. So I joined to the competition, I think, 3 weeks before the deadline, and I noticed that the data are noisy with a lot of missing values. So I postponed the feature engineering to the end of last day of the competition, but unfortunately, at the end, I ran out of time and don't have enough time for feature engineering, and I simply mapped season categorical feature to numerical values, and I used KNN imputer for filling the missing data in features. And that was it. I didn't do any other feature engineering. Here you can see the feature importance of my large GBM model in my base models. As you can see, that the age and physical height are among the most important features in my model. This ranking is by gain, and we can see if we want to rank the feature importance by the contribution to the split of trees in gradient boosting. Again, we can see that the sleep disturbance scales is the most important feature, and also the time spent on the computer is the second most important feature. Here I plotted some partial dependence between most important features and my target variable. And as it was, I think, obvious from the domain knowledge, you can see that there are some direct relation with features like sleep disturbance scale and times spent on the computer with target variable that we predicted. These are also some other partial dependence variable that I will skip them. For my training methods, I used a five-fold cross-validation with consistent random state across all folds. For my semi-supervised model, I use hill climbing approach to ensemble models based on their mean square error metrics. And for final model, I applied hard voting to ensemble the base models with equal weights. The key approaches that I believe that contributed to my success was the way of I extract information from time series by using clustering methods, using PCAIT total as a target label. I think helped me to ignore completely the threshold optimization and put my effort on my models, and also using sample weight in training regressor, I think was a important part of my job. As I said, it wasn't my idea, and using semi-supervised learning for unlabeled data helped me to improve my cross-validation score at the end. To simplify my model, I removed the time series feature and just used a single large GBM model for final prediction. And with this simplified approach, I got the score of 0.573 in my private leaderboard, which I could still a solid score. To have an overview of the whole competition, I believe that when we have evaluation metrics like Cohen's kappa, and where selecting the right threshold could significantly impact the result, I think the winning approach could often involve reducing the randomness of metrics. I saw a lot of participants use different seeds to reduce this randomness, but I tried to use as much model I could to reduce this randomness. And because that advantage I had in this competition, I think was my prior experience in ensemble method, which I use here again. And I think that ignoring the threshold optimization also was a big advantage for me. Most fun aspect of this competition, which I believe that was very challenging, and I think still there is a lot of room to work on it, was the time series data and how we can extract useful information from that data. I think it was very interesting. So thank you for your attention, and I am ready to answer any questions.